In this video, I'm going to talk about the surface area and the volume of pyramids and cones. So first, I want to define what a pyramid is. A pyramid is a solid with a base that is a polygon, and it has triangular lateral faces. A regular pyramid is a pyramid with a base that is a regular polygon, and it has its vertex over the center of the base. So you can see I have pictures here of both a regular pyramid and a non-regular pyramid and the parts. So in my regular pyramid, the vertex is directly over the center. That's not the case in this non-regular pyramid. So my vertices are the points where all my lateral faces intersect. The lateral faces are the triangular faces. They are the faces that are not the bases. I have an altitude drawn, which is the distance between the vertex and the base. You can see inside a regular pyramid, it's right inside there. But I have this pyramid over here, non-regular. It goes from the vertex and it measures the distance to the base. It's on the outside of it. Sometimes on the outside, but definitely not the center of that polygon. My bases are the polygons that can be regular or non-regular. And finally, the slant height is the distance between the vertex and the midpoint of one of the sides of my regular polygon. Notice I have a slant height for my regular pyramids and not for my non-regular pyramids. The slant height actually is the height of one of the triangular faces of my regular pyramid. Now, as we try to calculate volume and surface area of pyramids, it's really important that you identify within each pyramid there are several right triangles. So in my first picture, I have a right triangle formed with the height, which is the distance between the vertex and the base, the apothem of my regular polygon, and then also the slant height, and we abbreviate that with a lowercase l. I believe they chose that lowercase l because it is the lateral side's height. In the second picture, you can see I have another right triangle formed inside of that pyramid. In this case, it's formed with the radius of my polygon base, the height of the pyramid, and this is actually the lateral edge. In the third picture, I have a right triangle formed on the lateral face. This distance is the slant height. Then I have half the side length, and then also the lateral edge. So again, lots of times in formulas we'll need to use different lengths. These right triangles will help us find the lengths that are required. Now, I want you to see where the formulas come from. So I have a pyramid drawn here, and it's a regular pyramid, and actually it's a square pyramid. And I have formed a net of just the lateral faces. Now you can see that I've labeled each of the bases of my triangles S for side length of the base. The distance between the vertex and the midpoint of the sides is the slant height. And the perimeter of the base is this entire length here. Now we know the formulas for the area of a triangle. The area of a triangle is 1/2 the base of my triangle times the height of my triangle. And in this particular case, I have 4 of them. And I'm just going to rearrange a few things and rename. So I still have these 4 triangles. 1/2 stays the same. The base of my triangle is the side length of my the polygon. That's the base of my pyramid, so S. And the height of my triangle is my slant height. Now, Now I'm going to rearrange. I'm going to move the half out front and the 4 on the inside and regroup. And what you can see here is 4 times S is really the perimeter of the base. So the formula for a regular pyramid, regular being a really important word here, regular pyramid, is 1/2 the perimeter of my base times the slant height. Of course, I could always find the area of each of the triangles and add them up, but it is going to take me longer. So if at all possible, use this formula. Then, if I want to find the total surface area of my pyramid, you have to recognize that there's exactly one base. So I take the area of the base of my pyramid and I add it to the lateral surface area. The formula for the volume of a pyramid is 1/3 the area of the base times the height. So I want you to use these formulas to find the lateral area and the total surface area of this regular triangular pyramid with base edge length of 6 and a slant height of 10. Do that right now. Press pause on your video. When you're ready for the answer again, press play. So here is my answer. I first found the area of my base. Remember, this is an equilateral triangle, so the formula is the square root of 3/4 times my side squared. Plugging in, I get the area of my base is 9 times the square root of 3. I next turn to find the lateral surface area of my figure. That is 1/2 the perimeter of my base times my slant height. Well, each of these side lengths is 6. So the perimeter is 6 times 3, or 18. My slant height is given, which is 10. So 1/2 18 times 10 is 90. My total surface area is 9 square root of 3, that's the area of my base, plus 90, which is my lateral surface area. That is the exact answer. If I want an approximate answer, I have to plug that into my calculator, and you'll find that that is then 105.6. Now remember, surface area is in square units, and actually it told us it was in feet, so I'm going to go ahead and change that to square feet. Okay, next I want you to find the volume of this same pyramid. Press pause on your video, and when you're ready for the answer, press play again. Here's my answer. I found the area of my base earlier. That's still 9 square root of 3. But in my formula for volume, I need the height, not the slant height. And the height is not given. So I had to rely on this right triangle inside my pyramid that's formed with the slant height, the apothem, and the height. So using Pythagorean theorem, I solved for h, and h is the square root of 97. Then I went back and I plugged in my formula. 1/3 base, 9 root 3, times the square root of 97. That is 3 square root of 291, and that's cubic units. And I forgot here, that's still feet. So this is cubic feet. Volume is measured in cubic feet. And if you plug into your calculator, you'll find that that's approximately 51.2 cubic feet. Next, I have a hexagonal pyramid. It is a right regular pyramid. I want you to find the lateral area, the surface area of that regular, total surface area of that regular hexagonal pyramid. It has a base edge of 10 and a slant height of 16. And I also want you to find the volume. Press pause on your video. When you're ready for the answer again, press play. All right, so you can see I first found the area of my base. My base is a regular polygon, so the formula is 1/2 the apothem times the perimeter. So over here, I drew my hexagon, and I knew my side length was 10. The apothem cuts that side in half, so half my side is 5. I formed a nice 30, 60, 90 triangle. So since this side is opposite 30-degree side, this side is a root 3, so 5 root 3. So now I know my apothem times the perimeter. Each side is 10, so my perimeter is 10 times 6, or 60. I plug all this in, I get 150 square root of 3, and that's approximately 259.8. And remember, we're dealing with square units. Now, the next thing I did was I found my lateral surface area. My lateral surface area is 1/2 the perimeter of my base times the slant height. Now, what was I given? The slant height is 16, so that's good. I have that, so now I'm just plugging in. 1/2 the perimeter of my base is 60 times the slant height, 16, gives me 480 square units. Now, plugging into my total surface area, add my base plus my lateral surface area. That's 150 square root of 3 plus 480. That's my exact answer. Again, square units. When I plug into my calculator, I get 739.8 square units. Now I'd like to find the volume. Well, the volume is 1/3 the area of the base times the height. My height is not given here, so I have to use the right triangle that is inside of my pyramid. So I have a right triangle formed with my slant height, my apothem, and the height. So 16 is my hypotenuse. 16 squared equals height squared plus apothem squared. Plugging in, I find that my height is the square root of 181. I go back and plug in my formula. 1/3 the area of my base, 150 square root of 3, times my height, square root of 181, and then continue to calculate. That is 50 square root of 543. Remember, cubic units is volume. This is my exact answer. My approximate is what I get when I plug in my calculator, 1,165.1 cubic units. Next thing I'm going to talk about are cones. First, you need to know what a cone is. A cone is a solid with one circular base meeting at a common vertex in a different plane than the base. So here are two pictures of cones. I have a right cone and an oblique cone. In a right cone, the vertex is right over the center of my base. In an oblique cone, that's not the case. The vertices are where my lateral surfaces meet. Then I have a slant height that goes from my vertex down to the base of one of the sides, and it meets the base at a right angle. I have heights in each of these. My height is my perpendicular distance to the base. Same thing over here. That's my height over here. This is my height. We call the segment that attaches the vertex to the center of my base the axis. And then my bases are my circles. So some formulas go along with cones, and they're very similar to those of pyramids. That's why I grouped them together. So in a pyramid, my lateral surface area is 1/2 the perimeter of the base times the slant height. In a cone, the perimeter is called the circumference. So in a cone, my lateral surface area is 1/2 the circumference times the slant height. The total surface area of my cone is one of the bases, because I only have one, plus the lateral surface area. Now, you have to remember the base of a cone is a circle, so the formula for that base is pi r squared. The volume of the cone has the exact same formula as the volume of a pyramid. 1/3 the area of the base times the height of the pyramid. Notice here it's the height of, not the pyramid, cone. Notice here, this h is the height of the cone. It is not the slant height, so it's different. So in this example, I want you to find the lateral area and the surface area and the volume of this right cone with a radius of 5 centimeters and a slant height of 9 centimeters. Press pause on your video. When you're ready for the answer, press play again. Here's my answer. So I first found the area of my base. Remember, it's a circle, pi r squared, so the area of my base is 25 pi. To get an approximate answer, I plugged that in my calculator to get 78.5 square centimeters. The next thing I did was I found my lateral surface area. That is 1/2 the circumference of the base times my slant height. So I plugged in again, and I found that was 45 pi. The approximate answer is 141.4. And again, this is area, so it's square centimeters. Then I found my total surface area by adding my base to my lateral surface area. That's 25 pi plus 45 pi gives me 70 pi. So my total surface area approximate answer is 219.9 square centimeters. The next thing I did was I found the volume. I noticed that my volume required the height. I wasn't given the height, I was given the slant height. So I used this right triangle inside my cone, and the hypotenuse of that right triangle is 9. The radius is one of the legs, so 9 squared equals height squared plus 5 squared, solving for h. I got 2 square root of 14. Then I plugged back into my formula. 1/3 the area of my base, 25 pi, times my height, 2 square root of 14. I multiplied the 25 and the 2. That gave me 50. 50 pi square root of 14. I still have the 3 in the denominator. Then I plugged in my calculator to get an approximate answer. That's 195.9 cubic centimeters. This is my exact answer. This is my approximate answer. Next, I wanted to show you how to find the surface area and volume of a composite figure. In this figure, I have 2 cones that are right next to each other. They share a common base. I'd like you to find the surface area and the volume of this composite figure. Press pause on your video. When you're ready for the answer, press play again. So here's my answer. The first thing I did was I decided that I'd like to figure out what pieces need to get added together. So my total surface area of my composite figure is going to be the lateral surface area of my left cone plus the lateral surface area of my right cone. The bases do not contribute to the total surface area of my shape. They're hidden inside. So I found the lateral surface area of my left cone, which was 1/2 the circumference times the slant height, which was given. So 1/2 the circumference, 2 pi r, so 12 pi, times the slant height gives me 72 pi. My lateral surface area of the right cone, same formula, 1/2 the circumference of my base times the slant height. My slant height was not given. I found it by looking at this right triangle, which happened to be a 3, 4, 5 triangle. Leg squared plus leg squared is hypotenuse squared. I found that's 10. So the lateral surface area of my right cone is 60 pi. Then I added those two together. My total surface area of that composite figure is 132 pi. Again, square inches, it's area. I plugged it into my calculator to get 414.7 square inches. Next, I found the volume of my composite figure. To find the volume, I added the volume of my left cone to the volume of my right cone. And in this case, I needed to know the area of the base. The area of my base is pi r squared, or 36 pi. I also needed to know the height of my left pyramid. So you'll notice I used this triangle inside here. Height squared plus leg squared, 6 squared, radius squared equals hypotenuse squared. So I solved for h. When I did that, I got 6 root 3. Plugging in, I got 72 pi square root of 3. And that approximate answer is 391.8. Remember, these are cubic units because it's volume. Then I found the volume of my right cone. In this case, I had the height. That's what was given. So 1/3, 36 pi times 8 is 96 pi. Then I plugged into what I had decided needed to get added up to find the volume of my composite figure. That's 72 pi square root of 3 plus 96 pi. This is my exact answer. My approximate answer is what I get when I plug it in my calculator, 693.4 cubic inches. Here's another composite shape. You can see I have a cube and I have a pyramid cut out of that cube. I'd like you to find the surface area and the volume of this composite figure. Press pause on your video, and when you're ready for the answer again, press play. So here are my answers. First, I figured out what needed to get added up to find the surface area. I had the total surface area of my cube, but I subtracted one of the bases of my cube because this top part is gone. It's hollowed out. And then I had to add in the lateral surface area of the pyramid. Then I turned to find each of the pieces so that I could plug it back in here. The total surface area of my cube is 6 times 4. Now, there are 6 sides of my cube, 4 around the outside, 1 on the top, 1 on the bottom. So each of the faces is 4, 2 times 2, they're squares. So 6 times 4 is 24. And the area of one of my bases of the cube is 4. My lateral surface area of my pyramid is 1/2 the perimeter of the base times the slant height. So the perimeter of my base is 8. So 2 times 4 gives me the perimeter of the base. And then I need the slant height. To find the slant height, I draw a segment from the midpoint of the base to the vertex of my pyramid and up. So this is the apothem of that square, which is 1 unit long. And I know my height is 2. So my slant height is there. So I would find lateral height, or slant height squared, equals 1 squared plus 2 squared. So 1 squared plus 2 squared is 5. So my slant height is the square root of 5. So looking back over here, 1/2 the perimeter of the base, 8, times my slant height, square root of 5. So the lateral surface area of my pyramid is 4 square root of 5. And I plug all that into my original plan. So it's 24 minus 4 plus 4 square root of 5. Simplifying gives me 20 plus 4 square root of 5. That's square yards. Then plugging in my calculator, I get 28.9 square yards. The next thing I wanted to do was find the volume of my composite shape. In this particular case, I have the volume of my cube minus the volume of my pyramid. So first I found the volume of my cube. That's area of the base times the height, 4 times 2 or 8. Then the volume of my pyramid is 1/3 the area of the base times the height, or 1/3, 4 times 2, 8/3. And then the volume of my composite shape would be 8 minus the 8/3, which gives me 16/3 cubic yards. Plugging into my calculator, get an approximate answer, 5.3 cubic yards. Now notice, my pyramid that's the same height as this cube has 1/3 the volume of that cube. You could have looked at this if you had realized that and said, okay, well, what's left over is 2/3 the volume of the cube, which is essentially what I found here. So that concludes my lesson on surface area and volume of pyramids and cones. Have a great day. Check out the assignment online.